All right, why are we thinking about vectors? Well, mathematicians like to abstract things. So we already know how to work with a linear DDS with a little a and a little d. Now what we're going to do is we're going to have a system of DDS and how that's going to work. And it's really natural where it works. We talked about data where people don't come back for their clinical visits, but that didn't have an outcome. In the case of bariatric surgery, that would be weight. So you'd want another equation that shows how weight is connected to coming to your clinical visits. And so you really have two equations that are intertwined with each other. And vectors gives us the machinery and the theory so that we can treat those two-dimensional problems just the same way we did the one-dimensional problem. And so that's where we're headed to. But first you need some of the machinery of how to work with vectors, which is why you're getting these problems. So here you have 2 points. Points are different than vectors. They're Cartesian points in the Cartesian plane, the x and the y, and you plot them. And you're asked to find the vector. How you find the vector is let me show you how you would do that. Let's just draw what we're actually looking at. So here's my point A and my point B, and I forgot to close the parentheses. I'm going to do so on the next slide. So I drew my scale so I could actually have them appear. What is the vector AB? It's actually the ray that starts at A and ends at B. That's what it is. It's not points. How do you find the vector that goes through those 2 points? Well, we go tail to head. The tail of the vector is where the arrow is, and the head is where that started out as. And we just subtract. So tail minus head. So 5 minus 13 gives you your first coordinate, and 28 minus the minus 13 gives you your second coordinate. So we get minus 8, comma 46. This is the same ray, but it's picked up and placed at the origin. And I should have actually drawn it. You'll have 2 parallel vectors, but this one shoots out and it goes minus 8 up to 46. And it'll be parallel to that first ray that I've drawn. So all vectors in the math world are at the origin. That's because we don't need it. The location of it doesn't matter. Only the magnitude and the direction. And so the magnitude can be thought of as the length for now, and the direction is just the direction. It's going off to the left here. So I can just center it at 0, 0 and have it go off to the left. So that's what the next question here is asking you. What's the initial point of this vector? Well, it's 0, 0. It always will be because I just shift it to the origin. And that's it. We don't have any more. That's why it's making a noise. We're actually done. So if you have any questions again, contact me. And hopefully this is not that, it might seem a little out of sync, but it actually isn't. We're going to do some really cool stuff.